So we have a double riveted lap joint having zigzag riveting, and it has to be designed for 6 thick plate. So we have to design a double riveted lap joint with zigzag riveting, and thickness is 6 Given the tensile stress, shear stress, and crushing stress, given 100 megapascal, 70 megapascal, and 130 megapascal, we have to determine the efficiency and how does this rivet fail. We have to determine these two factor along with the we have to design it. So not designing a rivet means you have to find certain terms. Okay, that's what designing means. So let's look at the detailed solution. So first, writing the given condition, we have a double riveted lap joint having zigzag rivet. Okay, that's our arrangement here. Our thickness is given, and tensile stress, shear stress, and the corresponding crushing stress is also given. These are all the given condition, and this is the simple uh, front view of the double riveted lap joint. Okay, this is a front view. Won't be able to understand whether it's a zigzag riveting or chain riveting. Only on the top view. Okay, this is the front view. This one is a front view, and this is the top view. So only on the top view will be able to understand whether it is zigzag riveting or chain riveting. Okay, in the front view, it may seem we'll be able to understand whether it is a double rivet or single rivet from the front view. So we can see it is double rivet. Okay, so to get more specifically whether it is zigzag or chaining, just have to draw the top view. So I have drawn just three of the rivet to show it is a zigzag riveting. So the reason why I write the 1 by 2 and this 1 by 2 is I will explain later. Okay, that parameter is needed for finding a specific term in this solution. Just keep in mind always the number of rivets to have uh, when we count number of rivets we always take in between the each. Okay, I mean the center to center distance between two rivets. If you take the center to center distance, uh, since it's a zigzag riveting, minimum we need 3 rivet for comparing, right? So if I take center to center distance between two rivet in a row, so that means I can only take these two, right? So this is center to center distance. How many rivets are in between this? Okay, one full rivet is there and half and half. That means total two rivets are there. Okay, just keep that in mind. This is the way to find the number of rivets by this given question to find number of rivets. That number has to be determined by this method. You just have to take the number of find the number of rivets between the which is the center to center distance between the two rivets in the same line of row. So this is a 6R riveting. So it will be like alternate, like one rivet will be here, the other rivet will be on the alternate side. So this is the way in a 6R riveting look like. So if we take the center to center, there is one half, so one rivet and another one rivet. So total two rivets are there. Okay, so this number of rivets will be later needed in finding a certain parameter, which will explain that time. So you have to remember what I told you right now. That's why I told you right now. So another term we have to find number of rivets in single shear. That is N1. It is represented by N1 as well as number of rivets in double shear is represented N2. So here, how do you determine whether it's a single shear, double shear? So if you look closely, so the force will be applied in opposite direction. One will be around this point, and another force will be in this opposite direction. Okay, one force is here, and the force is here. So what really happens is two equal opposite force are applied in opposite direction. So this whole part is a rivet, right? So it will fail at this point, at this point between the joining part between these two plates. These are two plates. So it's a lap joint, so it will be overlapped to each other at this exact point here, also here. At this point, when these two forces are applied, it will be failed at exactly at this point. So there is only single shear happening at this point, right? There is no other part where it fails by shearing when these two, I mean, these forces are applied. If you take the case of this rivet, it will fail at this single part, and same as the take when you take this rivet, it will also fail at this point. So a single shear is happening at this rivet, right? So that's how to find whether it is single shear or double shear. So when does double shear happens means when additional one more plate is there, just there will be one more shear will happen at the same rivet. I mean, like this, just like this point, there will be also another point. If there is one more plate attached to this rivet, but there's only two plate and rivet system. In this case, when the force applied, there will be only shear acting at this. I mean, shearing will act at only one point. That means single shear. Okay, so double riveted lap joint will lay hook a single rivet, right? So how to find the number of rivet in single shear? So number of rivets in single shear, just take two. Okay, you may think there will be lot of, I mean, rivets there, but just it's a double rivet, and I mean, basically we consider the row. Okay, this there will be lot of rivet in this system, but we'll be taking the number of rivet in the front view or the row. If here only two rows can be seen from the front view, right? So just take that number simply. Don't think too much. Number of rivets are single. We know it is single share due to double rivet. Just like I explained, single share is happening right here, and there are two rivets at. I mean, basically two set. Okay, two rivets at where single share happens. So N1 is the number of rivets in single share. That is two. But there's not double shear here, right? If it want to occur in double shear, there should be one more plate. So there is no double shear. So obviously N2 equals 0. So the very first step to solve or finding designing in the case of a rivet is you have to find the diameter of the rivet hole. So diameter of the rivet hole is given by this equation. This is known as Professor Unwin equation. You can find this specific equation in the data book. So you can find this specific equation data book. This is diameter of the rivet hole. D represents diameter of the rivet hole. I mean hole diameter. So there is a range of value, and among that you have to always consider the larger equation, that is 6.325 root 3. We have thickness is given the question of 6 mm. For substituting, we get 15.4 mm as the diameter of the rivet hole. This is not the actual diameter. It is like more of a theoretical value. Okay, next step is, so the whole diameter has to be assumed as small d, and rivet diameter is small d1. And these are the certain equations you just have to by heart, not to solve this solution. Okay, if we know the value of d, how do you find d1? Okay, there are different equation based on the d range. Here we got d between 12 and 24, right? So I can take this equation. So the thing is, the diameter of the hole we got initially is not the standard diameter. Okay, so from the initial value, if I substitute, I will get as of 14.4 as the. So from the initial value, I got the rivet diameter as 14.4 mm. These are two. This is rivet diameter, whole diameter is all standard value. We need the standard value. So how do you find standard value? Okay, now I got small d1 as 14.4 mm. And if you check the data book, there is a prescribed value for a standard diameter range. So after 14.4, the next value according to standard range is 16 mm. So I should take the rivet diameter, standard rivet diameter D1 as 16 mm. Okay, now I got the value of actual standard diameter value of D1. So how do you find the standard hole diameter? You just use the same equation to find the standard hole diameter. You get the small d as 17 mm. So we got the hole diameter, the actual standard diameter is 17 mm. Okay. So next step for designing is to find the pitch of the rivet. So pitch of the rivet means we have to find the optimum pitch and maximum pitch. So we have to find the optimum pitch and maximum pitch. So optimum pitch, this equation is also in the data book. Just don't need to by heart it. So by using this equation, we get the optimum pitch as 52.9 mm. We also need to find the maximum pitch. Maximum pitch formula is K1T plus 41. So what is K1 is a constant value that's is find based on the number of rivets. Okay, that's why I said you to initially I told you like half and half that one. So from that value I got two, right? So if you look on the data book, there is a specific column. So it varies with the different data book, right? So there is a specific value able to find the value K1, which in which the corresponding value is the number of rivets. So that number of rivets from here it will be two. So based on that, the K1, these values all from the data book. Based on that, the K1 value will be 2.62. So maximum pitch value is 56.72. We got the value of both optimum pitch and maximum pitch. Here we have to take the minimum value for pitch. So comparing optimum and maximum pitch, the optimum pitch is having the lower value, so you should take that value. So 52.96 can be rounded as 53 mm. So the pitch P really got us 53 mm. Next step is to find the transverse pitch. This is also the next parameter in the case of designing of rivet. This equation can also be found in the data book. We know the value P, we just find out as 53 mm, and also D. D is the you know diameter of the rivet hole. So by substituting it to the answer, which is we get at approximately 29 mm. Okay. Next parameter is margin. Margin is center distance. I mean the distance from the center of the rivet to the edge of the plate. It is 1.5 d. Since we have the value of d, diameter of the hole, we can find margin also. The final step they asked is to find the efficiency, right? So how do you find efficiency? So efficiency, there are three types of efficiency. So first one, you need to find the tearing or plate efficiency, which is given by this equation. So if there are certain terms to get cancelled out, after cancellation it will be P minus D by P, where P is the pitch. We know the value of P. We have the diameter of the holes. We know both the value. So the tearing or plate efficiency is basically the efficiency. I mean, it could fail by tearing, right? So that efficiency percentage is like 67.9 percentage. Okay, so that's a chance, or I mean, percentage at which the tearing occur in the riveted system. So next is shearing or rivet efficiency. This is efficiency when it failed by shearing. It is also given by this equation. We have all the parameter n2 is 0. We know the n2 is 0. Number of rivet uh, failing by double shear is 0. So n2 is 0. We only have the value of n1. So substituting the shear efficiency will be approximately it will be 98, 99 percentage. It could vary based on the value, certain value you are taking. And final efficiency is crushing efficiency. These are the when they ask about efficiency, these are the three types of efficiency you need to find: hearing efficiency, shearing efficiency, and crushing efficiency. The last one is crushing efficiency, which is given by this equation. These all equation are in the data book, or you can just by heart this equation. We know all the value. Crushing stress is given in the question. So it will be approximately 83.3 percentage. So we have found out they asked to find the design, right? Design means we have to find the various parameters like diameter, pitch, margin. We find out all that term. Along with that, they already asked to find the efficiency, which is also we found out. In third thing they asked is how does this thing fail? So how do you think the Revit will fail? How on what parameter would tell this Revit would fail? We would tell by comparing the value of efficiency. These three efficiency are based on the three phenomena: tearing, shearing, and crushing. So we are comparing the efficiency of these three method. The lower value of efficiency is for tearing efficiency. The first one we find it to be approximately 67 something, right? So that is what actually the first thing that happened to the rivet. That means it would fail by tearing. Okay, tearing means 67 percentage only. That's the lowest efficiency. That means chance, I mean, the percentage is small, right? So it would fail by tearing. That's a first thing that happens based on these conditions. So how does this thing fail by? This will fail by this reverse system will fail by tearing. Okay, so we have to tell it by comparing the efficiency value of the three one. I mean tearing, shearing, and crushing. Okay, this is the way to solve this type of problem.